This video will be on the distribution of the sample proportion. Suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion is given by what we call p hat equal to x over n, where x is the number of individuals in the sample with a specified characteristic, and of course n is your sample size. The sample proportion is a statistic that estimates the population proportion. And going back to our notation, regular P is your population proportion, P hat is your sample proportion. Let's look at computing the sample proportion, make sure we're okay with that. The Harris Poll conducted a survey of 1,200 adult Americans who vacationed during the summer and asked whether the individuals planned to work while on summer vacation. Of those surveyed, 552 indicated that they planned to work on vacation. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. Well, N, the sample size is 1,200. X represents the number of individuals who said they plan to work on summer vacation, which is 552. Now to find the sample proportion, you take the 552, place it over the 1,200, and that'll give you 0.46. So the Harris Poll estimates that 0.46, or in other words, 46% of adult Americans who vacation during the summer plan to work while on vacation. Sampling distribution of p hat. For a simple random sample of size n with a population proportion p, the shape of the sampling distribution of p hat is approximately normal, provided that the relationship holds true of n times p times 1 minus p is greater than or equal to 10. If that holds true, then it's approximately normally distributed, which means that we can use the z-scores, the z-score application. So the mean of the sampling distribution of p hat is going to be equal to p, and the standard deviation of the sampling distribution is going to be equal to the square root of p times 1 minus p over n. So let's put some numbers on this. According to the National Center for Health Statistics, 15% of all Americans have hearing trouble. So let's look at A. In a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? And then B, suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing trouble. What might you conclude? Okay, so we'll look at A first. Well, before we look at A, we have to establish, do we have an approximately normal distribution? So N is 120, P, your population proportion, is 15%, which is 0.15. Now we put it in the relationship N times P times 1 minus P, so that's 120 times 0.15 times 1 minus 0.15. That's equal to 15.3, which is greater than 10. So since that's greater than 10, the sampling distribution is approximately normal. That means we can use our z-score application. So going to what we know, p hat is 12%. Our sampling proportion is 12%, so that'd be 0.12. According to the relationship, the mean of our sampling proportion is going to be 0.15. And then we can calculate the standard deviation of our sampling proportion by 0.15 times 1 minus 0.15 over 120. And then we take the square root of that, which is going to be 0.032596. Put that in our z-score relationship when we do p hat minus the mean of p hat over standard deviation of p hat. And that's going to be 0.12 minus 0.15 over 0.032596, and that will be negative 0.92. So now we can go to our z-score chart. Negative 0.92 will give us 0.1788. And don't forget, our chart gives us less than. And since the question asks us about at most, this means we want the values that are less than or the proportion that's less than. So the chart answer or the chart value is the answer that we need. So the probability that a random sample of 120 Americans results in at most 12% having hearing trouble is 0.1788. All right. So let's look at B. Going back to question B, it says, suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing trouble. What might you conclude? So before Going into A, remember they gave us the sampling proportion of 12%. This time they gave us a number of people that are having hearing trouble in that sample size. So that means we can calculate the sample proportion by doing 26 over 120, which is 0.217. Our mean and standard deviation will stay the same. And now we can use our z-score. So that'd be 0.217 minus 0.15 over 0.032596. So once again, they gave us a number of individuals who experienced this characteristic in our sample. So we had to find the sampling proportion before they gave us the percentage or the proportion, and we didn't have to calculate the sampling proportion. So throwing in our z-score to give us 2.06. Go to your z-score chart, 2.06 will convert to 0.9803. Remember that represents less than. Now the question asked us, what might we conclude? So we should explore greater than to see how unusual this occurrence is. So when we subtract that from 1, because we want to know the greater than, the proportion of occurrences that would be greater than the 0.217, and that'll be 0.0197. So the proportion is less than 5%. So that means it is an unusual occurrence. So that means the result we obtained is unusual, and that gives us one of two conclusions possible. The population proportion of Americans with hearing trouble who regularly listen to music using headphones is 0.15, and we just so happen to randomly select a higher proportion that have hearing trouble. So it's possible that what we could have done here is just selected a whole bunch of individuals randomly that have hearing trouble, or the population proportion of Americans with hearing trouble who regularly listen to music using headphones is more than 0.15. And remember, the difference between A and B is that we include the characteristic of using headphones. And so when we look at that possibility, the second conclusion is more reasonable. So whenever you're dealing with statistics, the numbers send you in a certain direction in which you would explore all of your possible scenarios, all of your possible conclusions, and then you look at the one that is most reasonable. And in this case, the second one is the one that is most reasonable, the most reasonable conclusion. Let me know if you have any questions with anything I've said.